uh, situation products of even isometries, arbitrary even isometries. So for as far as products of reflections, the only place that we haven't covered yet is products of free reflections. Even that we know for some special cases. So for two special cases, we remember that products of free reflections in parallel lines will give us what? So if L, M, N are parallel, then sigma N, M, L will be another reflection in a line parallel to the first three. In, say, S parallel to N enough. And another case that we do know how to multiply, what would be the result of multiplying three reflections, would be when the lines are concurrent. In that case, what would be the product of the three reflections? Would be another reflection in a line concurrent with M and L. In other words, intersecting all three in the same exact point. Okay, so let's now go to the products of even isometries. That is, what are the possibilities for even isometries? We have either rotations, correct, or half-turns. Or translations. Half-turns, of course, are a particular case for rotations. So let's start with rotations. Translations are kind of trivial, easy case that we already know what would be the result, right? If we multiply the two translations. So two translations are given, what would be the multiplication? What would be the composition of two translations? Composition of two translations will also be a translation, right? A translation. By which vector? So you should be able, if the vectors for the two translations are given, to figure out what would be the translation vector for the composition. So let's look at composition of two rotations. So we have two rotations about, let's say, the same center. Then the situation is obvious. We know the answer: C theta rho C phi. Of course, will be rotation about the same center, theta plus phi. And in that case, we know that rotations commute. And actually, that will be the only situation where they do commute. If they are rotations in different centers, then we will show that they do not commute. We have already, but let's recall this case. So we have rotation about, say, center A by angle theta and another center, say, B by angle phi. Then what would be the result? So to figure that out, what do we have to do? The easiest way to do it. Since both are even isometries, it's good to represent them as products of, in this case, two reflections. And not just in an arbitrary way, but in a way that would allow us to cancel something. So those are even transformations, isometries. We can write them as sigma, say, A sigma B. And here we would like to use the same line for the first one for rotation in center B as this last one for the first rotation. So we want to have something sigma b, sigma c, so that we could cancel the two in the middle. So what would be the most convenient line? The only one, in fact, to do that would be the line between the two, connecting the two centers. So take for line B, just line connecting the two centers A, B, and then line A would be uniquely determined. We have to go from B to A to get theta, a rotation in angle theta, so that would be theta over 2. And then for the second rotation, we represent it as rotation from line C to line B in phi over phi. So from C to B it would be phi over 2. So we have to construct something from B to C. So let's say this is line C, and from B, sorry, from C to B, since C comes first and then B comes second. So so from C to B we go by phi over 2. And this direction was from B to A. So if this is line A, then we have theta over 2 directed angle in the positive direction. So this becomes, after we cancel sigma b in the middle, sigma A times sigma c, and we have to see that this will usually be a rotation. Usually means in the case when these two lines intersect. So if they do intersect in some third point C, then the result is a rotation around the C. In which angle? In the angle from C to A. So we have to go from line C here to line A, and that is exactly the exterior angle of the triangle ABC. And this exterior angle is exactly the sum of the other two angles in the triangle. So theta over 2 plus phi over 2. So we have the rotation and twice the angle, which will be theta plus phi. Of course, we have seen already this in class, but to refresh your memory, we now can state it as a theorem that composition of two rotations is a rotation in the sum of the angles, unless these two lines happen to be parallel. So they are parallel when theta over 2 plus phi over 2, when this angle, sum of these two angles, is exactly 180.